In these two examples, we're going to be using the properties of logs in order to find a given log. So for the first one, the product property, if you have terms being multiplied on the inside here of the argument, you can expand as addition. So you separate each variable in its own individual log, and you put a plus sign in between them. So we are given that log base 7 of 2 is approximately 0.356. They want us to use that in order to find log base 7 of 98. So the first thing you want to ask yourself is, how can I use a 2 in order to get 98? Well, if I take half of 98, that would be 49. So 2 times 49 would give me 98. So log base 7 of 98 is the same as log base 7 of 2 times 49. So all I did was rewrite 98 using a factor of 2, which is 2 and 49. From here, I'm going to be using this rule that says if you're multiplying two things inside the argument, you can expand them individually, right, by adding. So this means I would have log base 7 of 2 plus log base 7 of 49. I do know what log base 7 of 2 is. They gave me that. It's approximately 0.356. And I can actually evaluate log base 7 of 49. You're saying 7 to what power gives you an answer of 49? 7 squared, or 2. So if I add these together, I get 2.356. For the quotient property, this is what the quotient property says. Inside the argument here, if you're dividing terms, you can separate individually by subtracting each of them. So we are given that log base 6 of 30 is 1.898 and log base 6 of 2 is 0.387. How can we find log base 6 of 15? So again, how can I rewrite 15 using the two given values, the 30 and the 2? Well, if I take 30 and divide it by 2, it gives me 15. So log base 6 of 15 is the same as log base 6 of 30 divided by 2. So again, all I did was rewrite the 15 as 30 halves. From here, I can use this quotient property. I can rewrite as subtraction. So this is equal to log base 6 of 30 minus log base 6 of 2. Log base 6 of 30, they gave me that. It's 1.898. And log base 6 of 2, they also gave me that. It's 0.387. So if I subtract these, I get 1.511.